Today we are working on 4.2, greatest common factor. Greatest common factor, the first thing that we're going to do is we're going to do a little bit differently than we did last year. Okay, so step one for greatest common factor is going to be to do your prime factorization. Okay, so step one, prime factorization. So I'm going to come down to 24 and I'm going to break that up into 6 and 4 and 3 and 2. And then 2 can break down into, or 4 can break down into 2 and 2, and all of those are prime. 60, I'm going to break down to 6 and 10. 6 I can break down to 3 and 2, and those are prime. 10 I can break down into 5 and 2, and those are prime. And then 36, I'm going to break down into 6 and 6. Oh, that's not prime, my bad. And then break that down into 3 and 2, and both of those are prime. 6 down into 3 and 2, both of those are prime. Now what I'm going to do is, for the greatest common factors, I'm going to list out all of my factors in a more organized fashion. So I normally put them right on top of each other. So for 24, and I do it from least to greatest. For 24, I had 2 times 2 times 2 times 3. For 60, I had 2 times 2 times 3 times 5. And for 36, I had 2 times 2 times 3 times 3. Okay? So first step is what we just did, prime factorization, and then make it in a nice organized fashion. Step 2 is how you find your greatest common factor. And step 2 is you take what they have in common. So you take what they have in common. Well, what do I mean by that? Well, I literally mean take what they have in common. So what do these have in common? They have a 2 in common, all of them. They have another 2 in common, all of them. And they all have a 3 in common. Okay? These others, this 2, the 5, and the 3, they are not in common, so we don't count those. So what are we left with? Well, we're left with a 2 in common, another 2 in common, and a 3 in common. So to find the GCF, we simply multiply what we had in common. Well, 2 times 2 is 4, times 3 is 12. So what is the GCF of these three numbers? The GCF of those three numbers is 12. And we did that by doing the prime factorization and then taking what they had in common. Now, all three of them have to have that number in common in order to put it down. Notice how we only, even though if we look right here, it looks like there's 3 2s, but they all have 1 2 in common. That's where we have 1 2 here. Okay? Try this one by yourself before watching me do it. All right, I'm going to break 25 into 5 and 5. Those are both prime. 40, I'll do 4 and 10. 2 and 2, prime, prime. 5 and 2, prime. 55, let's do 5 and 11, and both of those are prime. So now I'm going to do my organization a little bit. For 25, I did 5 and 5. For 40, it was 2 times 2 times 2 times 5. And then for 55, it was 5 times 11. Well, if I look at this, do I have any 2s in common with all three of them? No. The only thing I have in common for all three of them is 5. So what is the greatest common factor of 25, 40, and 55? 5 is our greatest common factor because that is the only number they have in common. Relatively prime. Relatively prime is when two numbers' greatest common factor. So when the greatest common factor for 2 or more numbers is 1. Okay? So two numbers are relatively prime when its greatest common factor is only 1. So if we look at this example, 35 is 5 and 7. And 54 is 9 and 6. 9 can be broken down into 3 and 3, and 6 can be broken down into 3 and 2. All of those are prime, and if we look at these two numbers, we've got 5 times 7 and 2 times 3 times 3 times 3. None of these are in common, so that means the only factor that they have is 1, and so they are relatively prime. GCF of monomials, okay? So we basically just do what we just did with just regular numbers, except this time you're going to do it with monomials. First step from before is factor it out, do the prime factorization. Well, the prime factorization of 18 is 9 times 2, and then 3 times 3. So this is going to be 2 times 3 times 3. But then we can't forget about this guy. So we have times 1x, and then how many y's do we have? 2. So times y times y. For 28, 14 times 2. 14 can be broken down into 2 and 7. So I'm going to have 2 times 2 times 7. And then don't forget about your variables. I have 2 x's, so I'm going to break down 2 x's, and I have 2 y's, I'm going to write down 2 y's. Now, just like we did with our regular numbers, we have to find out what's in common. Well, what do they have in common? They have a set of 2's in common. Okay, so we're going to have that. They don't have any 3's, they don't have any 7's. They have 1 set of x's and 2 sets of y. So to find the GCF of these two things, we take what we had in common. We had a 2 in common, we had an x in common, and we had 2 y's in common. Well, how else can I write that? That would be 2xy squared, which would be your final answer of the greatest common factor of these two monomials. Okay? You try this one by yourself before watching me. Well, I broke down 22 into 2 times 11, so it's 2 times 11 times 3m's times p. And 38, I'll divide it by 2 first, and 38 divided by 2 is 19. Both of those are prime. So this is going to be 2 times 19, and then we have 1m and 2 p's. Now I'm just going to simply take what's in common. Well, what's in common this time is 1 set of 2's, a set of m's, and a set of p's. So I write down my what's in common, which would be a 2, 1m, and 1p. So your final answer would be 2mp for the greatest common factor of those two monomials. Good job. Check it over, read it over again, make sure that you're understanding what's going on.